This is a history of telegraphy from the Teletype Museum. I'm Ransom Slayton, a consultant with 36 years as a teletype engineer before retirement. The Teletype Museum display was set up several years ago by Charlie Hill and Ken Lovett and served for some time as a magnet attraction for visitors to the teletype plant. Later, due to the compelling demand for more office space as the company expanded, the museum was dismantled and the equipment on display was sent to storage. A record set of slide pictures was made just before this occurred, and this program is a walkthrough of the museum as it appeared in its better days. Join us for a trip back into the history of the telegraph art as illustrated by the machines developed by the inventors who contributed so much to communications progress in the old days. Our greeting is an appropriate start here with the beginning of a series of numbered captions covering various steps in the history of telegraphy. Early forms before 1820 included semaphores and electrochemical signaling methods, but historical records tell of signal fires, smoke signals, and even an encoded torch system in which the lighted torches were placed in numbered notches on top of high walls, the combinations of torches thus indicating the letters, numbers, or pre-selected words being transmitted. It was great for both day and night, but look out for rain, snow, or fog. Most people think of telegraphy in terms of the old Morse code key and sounder, so this was the first display. The sounder had a reflector box behind it, amplifying the clicks of the dots and dashes to the operator's ears. Behind the key was a power supply that permitted the station set to be demonstrated. Here the operator was working the key, actually sending a message as the picture was being taken. Morse's first telegraph system was not manual like this. Instead, it was automatic with sending from the set of notched blocks that cooperated with the sending contact. The blocks were placed on the perimeter of a large wheel that was turned by a clockwork system, with the operator picking the blocks out of a compartmented box, much as an earlier printer would set type, then putting the pieces back after transmission. Morse actually consulted a printer in selecting the codes for the various characters, making the most frequently used ones shorter so as to get the best transmission efficiency. The sounder was not usually placed in the telegraph line circuit, since its impedance was too high. Instead, a line relay like this would be inserted in the line. Again, Morse's original system did not use the sounder, but had a pen attached to a receiving magnet that would move the pen down to mark a moving paper strip when current was received over the line, a mark signal, allowing the pen to be lifted up when no current was present, a space signal. The strip was pulled through the recorder by another clockwork set. The receiving operator was then supposed to decipher the recorded message and write it down on a telegram form. When it was found easier, and it took less equipment, to decode directly from the clicking of the recorder, the sounder was developed. Also, it was much less work to operate a sending key than to handle the clumsy set of notched transmitting blocks. This cost reduction change set back automatic telegraphy by some 65 years. Several early electric telegraph developers were at work in the early 1800s, with Morse's writing instrument coming along in 1835. His demonstration to Congress between Washington and Baltimore with the famous message, "What hath God wrought?" was not accomplished until 1844. In 1836, much activity occurred, with Gauss and Weber, Steinheil, Cook, and Wheatstone all making contributions. Needle telegraphs and the related dial system, all using sensitive galvanometers as indicators, were actually put into commercial use in England and on the continent for many years. Wheatstone's contributions were many, including this type of sensitive relay named after him. A polar type, it turned out to be very useful when automatic telegraphy came along. Another of Wheatstone's inventions was the automatic recorder for signals which drew dots and dashes on linearly moving tape, much as Morse's first recorder had done. And the Wheatstone transmitter, which sensed the perforated tape, which had a row of small feed holes down its center line and larger code holes on either side of them. When the code holes were sensed, the dots and dashes would be emitted to the telegraph line. Edward Kleinschmidt, one of the later contributors, developed a keyboard-operated tape punch for the automatic Morse tape systems, and this was manufactured by Teletype for many years. Our wall captions now get around to Samuel Finley Breese Morse, while the next panel records the contributions of House, Hughes, and Phelps. Then we find the Baudot telegraph system given prominent display, Baudot contributed the equal-length code to the art using a constant 5 current impulses per character instead of the variable dots and dashes of the Morse code. In each impulse, one of two conditions occurs: a current for mark or a no current for space. Two impulses, later called bits, give 4 conditions, 3 give 8, 4 give 16, and with all 5, 32 different characters can be sent. With 26 combinations needed for the alphabet, the others are used for spaces between words, the shift and unshift functions to get another case for numerals and punctuations, and the carriage return and line feed functions for page printers. This leaves one extra, the blank or all no current combination, which can be used for tape feed out between messages, and so on. Baudot made a tape reader for his system, shown here. And his type wheel style printer was widely used in Europe. Its general design was used in a later teletype product, the Model 11. Actually, his form of 5-level code was applied to the French language, and the code we use and call Baudot was really developed by an Englishman named Murray for the English language. Murray is listed among the late 1800s developers along with Wright, Rowland, Buckingham, and Barclay. Barclay was represented in the museum display by one of his printer mechanisms, but little is known about it. The beginnings of the teletype story occurred in the early 1900s when a young man named Frank Pern came to Chicago to try to get support for the development of his ideas for a printing, telegraph, and linotype operating system. The story is recorded in a photocopy of a page from the Chicago Tribune dated Sunday, March 3, 1901, where Pern is shown operating his system using a modified typewriter. He secured the support of Joy Morton of the Morton Salt Company and went to work with Charles Crum of the Western Cold Storage Company, a Morton interest. Pern's typewriter was apparently a Remington No. 6, one of which has been preserved. He connected electromagnets and contacts to the mechanism so it became an automatic send-receive printer for a telegraph line. The printed copy was not immediately visible when recorded. The carriage had to be rotated upward to read it since the printing was accomplished by upward strokes of the type bars, which impacted the ribbon against the paper that was on the underside of the platen. Evidence of the early work of Crum and Pern is shown by a keyboard-operated device with the title, the Crum-Pern Teletype, inscribed on it. A relay bank was mounted behind the unit, and one of the typewriters of this vintage was apparently mounted on top of it. Some of the mechanism appears very modern, including the use of code bars to set up transmitting contacts. The later history of the unit is intriguing. Your narrator found it in a storage at the Teletype Wrightwood plant in Chicago in the late 1950s. Painted solid black, it was not readily identifiable. However, a bit of the gold legend showed where the black paint had flaked off, so we scratched off more of the paint, gradually exposing the complete legend. It appears that this was the first joint effort of Crum and Pern. While the legend says patent applied for, no patents appear to have been issued to the two men jointly. Instead, when Pern broke off his relation with Crum, the latter seems to have kept and used it as a test bed for further experimental work, painting it black to cover up the evidence of the earlier connection. Several years later, Crum alone filed applications and was granted patents on the keyboard arrangements found in the model. Charles Crum continued his work on experimenting with electrical circuits and controls and on design of printing telegraph circuits, making use of commercial typewriters. He was joined by his son Howard in 1906, and such progress was made that the Morcron Company was formed the next year using Morton family financing and Crum engineering. The first full experimental set assembled by the Crums consisted of a relay bank attached to a modified Oliver typewriter, which was one of the most popular machines of the day. The relay bank served the line functions of transmission and reception of telegraph signals, which consisted of 5 impulse intervals, the first and last of which defined character limits. The middle 3 could be either positive or negative polarity and of one of 2 strengths, thus giving 64 character permutations. When a character had been received, it was decoded through another group of relays in what we now call a Christmas tree pattern. Many of the individual relays were designed by Charles Crum, and he had been granted patents on them. The Oliver typewriter used has been preserved with one exception. Someone stole the platen from it many years ago. It was modified by having an enlarged cast iron base, and below that had a larger sub-base that was not required by the original manual typewriter. The key levers were still attached directly to the type bars, which consisted of U-shaped members located above and to each side of the printing point. When a key lever was depressed, the type bar rotated sideways and down, impacting the ribbon and paper which were facing upward at this point, providing visible copy. The platen moved sideways for character spacing and line return. It also moved forward and back to give three cases of printing: capitals, lowercase, and figures with punctuations. Thus, each type bar had three characters on its type palette. The whole arrangement was somewhat clumsy and the operating speed was very slow. The key levers were modified in two ways. First, levers were attached which hung down into the subbase area, providing connections to a bank of electromagnets located in the subbase. Here, the magnets are shown with the finger pointing to an armature extension which would engage a corresponding hanging lever. Operation of the magnet would cause the key lever to be pulled down just as a finger would push it down from above, thereby printing that character. Set of transmitting code bars were in front of the receiving magnets. These worked in conjunction with plates with square notches that were attached to the various key levers, each plate being coated with notches in its special permutation. The code bars were, in turn, caused the opening and closing of electrical contacts that were sensed during the transmission function. Further front was a transversely mounted universal bar that rotated each time a character was being sent. It locked the key levers in their positions during the sending interval, by going over or under small horizontal projections on the key levers. The Crumbs soon found that commercial typewriters were not rugged enough for continuous use as telegraph terminals. They accordingly studied typewriter mechanisms and then designed their own parts to the required standards. This was done in general in succeeding years except for one variation, the Model 12 printer. The typewriter chosen for emulation was called the Blickensderfer. It was quite popular, especially since it had advanced beyond manual operation, with one model being motor-driven, the first electric typewriter. Printing was by a type wheel mounted on a vertical shaft and having three rows of type on its periphery. The wheel was raised to match the desired case and rotated to the selected character position. It was then swung toward the paper, contacting an inked felt roller which put ink on the typeface. The roller was then pushed out of the way as the wheel impacted the paper, printing the character. During the stroke, the wheel was locked into position by having a notched gear underneath it encounter a corrector blade, thus printing the character at an exact spot. The Crumbs had also come up with the start-stop idea of character synchronization, and they proceeded with intense development of it. The idea was to have just one polarity of signaling and one strength of current. Also, code impulses were to be contiguous, not separated as in earlier systems, and the no current condition would also be used as a start signal, causing the receiving device to look for received code impulses as they were being generated by the transmitter. The character would end with a current condition called stop. Thus, absolutely precise timing would not be required since corrections were being made with each character. The initial product line using the method was the blue code, first sold to the Postal Telegraph Company, no models of which have been preserved. The next products were very similar and were called green code for the color of paint used on them. Postal Telegraph's color was blue, while Western Union, for whom the next line was developed, used an olive drab or green color. A green code printer and keyboard perforator have been kept. The perforator, called a GPE, green code perforator, was designed about 1913 and continued to be produced for the next 50 years, a corporate record. It was magnet-driven and was very fast, being a workhorse during 2 world wars and the intervening expansion and depression eras. The blue code printer had 3 rows of type like the old typewriter. The green code had only 2 rows, capitals and figures with punctuations. It appears Western Union did not want the lowercase alphabet, preferring capitals only as being more efficient of operators and transmission time. It can be seen that the typewriter mechanism was almost exactly duplicated down to the felt inking roller, except that the paper was now stationary and the type wheel moved back and forth across the page on a carriage. Tape that was prepared on the perforator was transmitted by a reader-distributor unit which also contained a receiving distributor. The unit is shown here in its normal position between the GPE and the printer. This closer view shows how the tape came out of the perforator and went through the reading portion of the transmitting unit. The sensing was actually on a drag basis, with sensing fingers riding on top of the tape and entering the code holes as the latter passed under them. This in turn closed electrical contacts which were in series with the sending distributor. The line of code holes was not exactly perpendicular to the center line of the tape, a slight tilt allowing sequential reading. The distributor was a brush and commutator type with the segments consisting of round button contacts, not the square or rectangular ones used later. Apparently, the round ones were cheaper to make. A motor drove the distributor through friction clutches. The receiving distributor was on a parallel shaft driven by the same motor. It had smaller round buttons which allowed detection of received code impulses at their most reliable points near their centers. And it had a rangefinder system of rotating the faceplate back and forth to find the best point for operation. An interesting feature of the set is a flyball-type motor governor with associated contact that regulated the motor speed. The next product to be developed was the Model 11. It was faster than blue and green code units, but not by much, being about 45 words per minute. Here it is, with its cover closed. And now with the cover open. It was a tape printer, with the tape being gummed on the backside so that it could be pasted onto a telegram blank. Various styles of moisteners were used, each having a container of water and a felt wick. One feature first developed for the Model 11 was that of cushioned key tops, which had small springs inside them. The tops were also a soft material, and the combination had a good feel according to the typist using the keyboard. This feature was carried over to many later models during the succeeding years until replaced by cheaper molded plastic. Another new feature was the motor-driven cam and contacts type of sending distributor, which took the place of the brushes and faceplate type. This too was carried over to many succeeding models. And the governor began to look like later versions, but the control was still on the outside with an adjusting screw giving precise settings. White dots on the periphery of the governor were used in conjunction with vibrating tuning forks to set the motor speed. The governor had heavy weights within it, their positions during rotation being transferred to a plunger on the shaft axis for working the external contact. Next came the Model 12, which used commercial typewriter subassemblies as was noted before. Typewriter manufacturers L.C. Smith and Woodstock contributed the platen assembly and tight basket components. The printer was of the moving platen type and always seemed to have problems with paper feeding. The roll of paper was hung at the rear, and the web of paper coming off it was passed down under a guide bar to strip it from the roll and steer it up to the constantly moving carriage. Separate motors powered the typing unit and the distributor unit that was used for start-stop service. The typing unit contained latching relays that accepted signals from the start-stop or a multiplex receiving distributor. This well-preserved Model 12 start-stop set was used by the Chicago Police Department for some 35 years before it being retired in favor of new Model 28 equipment. A power supply for furnishing DC to the set circuits occupies the shelf under the tabletop. A close-up with the set cover open shows the two distributors. The sending distributor is the familiar cam and contacts type. Surprise! So was the receiving distributor, but with a difference. Instead of being closed for the full length of its code pulse, a contact closes only briefly during the center of the pulse interval, thus making the selection at the most reliable point. The multiplexing of telegraph signals, that is, sending two or more messages simultaneously, has a long history. In fact, an inventor named Moses Farmer had a patent on such a system granted in the 1850s. The unit shown is a Western Union multiplex sending-receiving distributor utilizing the brush and segments principle. It could be 2, 3, or 4 channels depending on the selection of the faceplate. The Morse multiplex differed by using motor-driven rotating cams and contacts in its distributors. Both types of muxes were driven by tuning forks, one of which is shown here. Howard Crum and J.O. Carr of Morcrum got the basic patent on this type of a drive in 1930. As the fork vibrated, it fed alternating pulses to the windings of the synchronous motors driving the rotating brushes or cams. The Western Electric Company made a complete line of printing telegraph equipment using designs provided by the Bell Telephone Laboratories and their predecessor, the Western Electric Research and Engineering Department. And while not generally known, AT&T owned Western Union during World War I and was forced to spin it off to maintain competition. One Western Electric product was the 1A printer, a model of which has been preserved. It was electrically operated, being controlled by relays and powered by magnets. Its printing element was a small type wheel mounted on a vertical axis. The tag indicates that the unit came from a Rockford newspaper after many years of usage. We now come to an interesting era of printing telegraph development. The name on the wall chart is Potts. Dr. Louis Potts was a most prolific inventor in the first half of the 20th century with almost 200 patents granted. He came to Teletype after the acquisition of the company by Western Electric in 1930. He had earlier designed this page printer which used many unique principles, but had never gotten it into production. The printing element is a type wheel mounted on a horizontal axis which moves back and forth in front of the stationary paper. Dr. Potts anticipated the need for more efficient handling of messages at a time when most were being manually relayed from office to office. His solution was to have the shifted F cause the message to be reperforated or switched to an outbound telegraph line at the distant relay point, while the shifted S would cause it to be printed out there, so it became a city copy that could be delivered by messenger. We now come to the other half of the Morse-Kleinschmidt equation. Edward Kleinschmidt was an inventor of the Crum and Potts generation who had his own business in Brooklyn, New York, which was a separate city before it became one of New York City's boroughs. He designed and produced a competing line of apparatus and had so many patent conflicts and suits with the Morcom Company that the two had to merge in the mid-20s in order to get a viable survivor. We have no models of his 3A or 3B units. A Model 5 entitled Kleinschmidt telegraph typewriter was much like its predecessors except that it was a single magnet type with pin barrel selectors operating on the start-stop principle. The printing type basket was stationary while the platen moved from side to side, thus contributing to paper handling problems. All this is explained in the printout being held in front of the unit. As far as we know, the machine was not operable, so the print copy was made on another machine somewhere. The legends on Kleinschmidt's keys were similar to those on Potts. The Models 3A, 3B, and 5 evolved into the Model 21A, a multi-magnet tape printer that was used in goodly numbers on the multiplex systems of the post-World War I era. It was entirely electrical in operation, having selecting and transfer magnets and a solenoid-powered printing and spacing drive. Its relation to the previous printers is easily seen by placing it alongside the number 5 while lying on its back. The type baskets are identical and many other parts are common. This was standard practice all down through the history of printing telegraph apparatus. Use what worked already if you could, and invent whatever was not yet available. At the time of the formation of the Morcom-Kleinschmidt Corporation, Howard Crum and Sterling Morton were collaborating on the development of what became the Model 14. Both men were of the younger generation that had taken over the business, but the new name was so clumsy that after a couple years of suffering, it was changed to Teletype Corporation. The Model 14 was a motor-powered tape printer with some familiar features. These included the cushioned keytops mentioned earlier, which are very visible in this close-up. This model has a fraction above the C, so it was used in brokerage service where stock quotations were in eighths of points. And note that the bell was above the S, since communication was now direct point-to-point with no relaying. And here's the cam and contacts type of sending distributor, which was driven by a sliding ratchet-tooth clutch. The principal innovation was the new single magnet selector, invented and patented by Howard Crum. The story is that the first sketches were made on a napkin on a hot dog stand in Coney Island while on a business trip to New York City. Negotiations became snarled, so the conferring group adjourned to the beach for recreation, where inspiration suddenly struck Howard. The single magnet selector operated code bars that cooperated with pull bars, which were part of the type basket. When a character had been received and transferred to the code bars, the motor operated a semicircular printing bail that moved upward to catch a notch on the selected pull bar, causing the type bar to swing out and down to impact the ribbon against the tape, a narrow platen, printing the selected character. At the same time, another pull bar was being selected and caused the spacing of the tape on the return stroke. There were 2 characters on each type bar with a fig ship, causing the printing of numbers and punctuations by moving the platen outward the appropriate distance. It was pulled back to normal by the letter shift. The Model 14 typing unit was also called the FP for 14 printer. The governor had internal contacts with collector rings on the outer periphery. Later, the collector rings were moved to the end of the device as shown on this model. The speed could be adjusted while the motor was running by pushing the small lever away from the motor casting in one case or pushing the upward projecting plate toward the motor in the other. Of course, the black and white target would be observed through a vibrating tuning fork tying extensions while doing the adjustment, speed being correct when the pattern was stationary. A complete Model 14 printer set was donated to Teletype by Illinois Bell. It is in perfect condition, having been given only moderate use by operators and wire chiefs on TWX circuits. TWX stands for Teletypewriter Exchange Service, and was a manual telegraph system that paralleled telephone service on a point-to-point two-way basis. The set includes a table with a power supply on a shelf under the printer. A close-up shows a special dial with pointer projecting through the cover. This was used in taking ranges as a distant customer or repairman transmitted to the central office while making adjustments or troubleshooting. And here's that security problem again. The handle for working the ranging apparatus is missing. Only the shaft shows by the lower hand. The Model 14 line was expanded by taking standard parts assemblies and adding new ones to provide new components for punch tape systems. The non-typing reperforator, called an RPE, was one such unit. This unit punched tape much like the old GPE, but did so in response to received telegraph signals. One version of the GPE did the same thing, but did not get into production. The RPE unit had its tape supply on top in line with the tape punching block, shown here. Since the punch pins moved upward to penetrate the tape, a chad-carrying chute was required, which allowed the chad to be moved upward and sideways before falling down into a collection box below. The lever projecting upward at the left was a backspacing control used by the operator if a mistake had been made that was to be canceled by overpunching with rub-outs, the all-mark combination. Here is the chad collecting box mounted below and behind the punch assembly, and at the lower front is the single magnet selector assembly taken without chains from the Model 14 printer unit. It was mounted in a vertical position, however. Another component of the punch tape line was the Model 14 transmitter distributor, also called the XD. This was a tape reader modified from its use with a Morse multiplex, where it was magnet-driven, to be stepped by a motor. The distributor was a rotating brush and segmented ring type, also driven by the motor through a felt clutch. Note that the motor is now a synchronous type. These came into use after the power company stabilized the frequency of the power system so that electric clocks would keep good time. This happened in the late 1930s. Henceforth, governed motors would be needed only on uncontrolled AC or on DC, which was still common. The Model 14 printer unit was worked over to become a typing reperforator through the addition of an RPE punch block, via which holes were punched in wide tape some 6 character positions to the left of the printing point. Also, the holes were not completely punched out, the chads hanging by hinges at their left edges, allowing the printing to be retained and read by the telegraph operators. This was the basis of torn tape systems developed for postal telegraph and military organizations during World War II. The typing reperf was called an FPR, 14 printer reperforator. A reperforator makes tape from received line signals, while a perforator makes tape from manually keyboarded input. One step further was the typing reperforator transmitter distributor. It was a Model 14 typing reperforator modified so that the last character punch actually appeared in a tape outside of the punch block. As tape was punched, the tape loop was formed by a depressing lever hanging down and passing through a slot into a tape collector under the table or shelf on which the unit was marked. This was called an FRXD. To the left of the punch was a climbing transmitter, which was a very narrow mechanism that was pivoted at its lower end. When an outward connection was made, the transmitter began reading the punched message, sending it to the distant receiving point. The dangling loop of punch tape, if present, was gradually used up, and if no further message was available, the reader pivoted and walked its way along the tape toward the punch block until it sensed the last character punched and stopped. This unit had only a short product life, being obsoleted by other less cumbersome switching systems that used electronic message handling means. We now come to the Model 15 line, which was to become the principal product of Teletype Corporation for many years. The first components were being developed in the late 1920s, and on October 1, 1930, the company was purchased by AT&T in order to get manufacturing control of the new product line that was to be used in the emerging TWX service that was offered the next year. Teletype was assigned as a subsidiary to the Western Electric Company, and so could be considered to be an adopted stepdaughter of Ma Bell. The principal product in the Model 15 line was the page printer. No such unit was displayed in the museum, but the Model 19 had the same printer components and will serve to describe its features. The printer was a stationary paper, moving type basket type, in which the basket from the Model 14 was used. The M15 printer was called a BP for Bell printer. The type basket was laid on its back and moved back and forth in front of the paper on rollers that rode on horizontal rails. The code selections made by the selector were transferred to horizontal vanes below the front rail, which were rotated up and down in correspondence with the marks or space of the code pulses. Levers then transferred the code combinations to the code bars on the type basket. A printing bail, the two parallel blades to the rear of the pointing finger, then moved forward, causing the front end of the selected type bar to swing up and impact the ribbon and paper, printing the character, and then moving the type basket one character to the right. The platen was moved up or down for figs and letters case shifts. The conventional single magnet selector was used, mounted vertically as in the RPE. Earlier selector magnet assemblies were of the pulley magnet type, in which the power derived from the signal line current or from a local relay contact circuit provided the selection effort. This printer has a holding magnet type selector in which the power was supplied by the motor-driven selector cam, which pushed the magnet armature to the operated position between selection intervals, then allowed it to release if the line was in the spacing condition. This relieved the line or local current source from providing appreciable power. The associated keyboard was a plug-in unit that mounted under the printed unit. Calling a BK, it used the conventional cushioned keytops, and most parts were from the Model 14. Transmission is from a cam and contacts type distributor that was similar to the Model 14. This particular keyboard has auxiliary contacts mounted above the distributor. One complete Model 15 set has been preserved. It was one of the military models manufactured during World War II and was used extensively throughout the conflict. Teletype worked around the clock making them. The Model 19 was a variation of the Model 15, differing in that the keyboard unit included a tape punch and a line character counter. These were provided so that simultaneous punching and set transmission could take place, the latter being from a tape reader with the printer copying the output. The reader was an XD unit which was located to the left side of the tabletop on which the set was mounted. The particular set on display was donated to the museum by Illinois Bell upon being retired from service when replaced by more modern equipment. The tape punch and character counter are quite evident. A power supply occupied a shelf in the back of the table. The keyboard perforator counter unit was called a PEX. Another variation of the Model 15 was the Teletypesetter perforator, which was designed and produced for the printing trades. The Teletypesetter perforator had 4 rows of character keys and punched extra-wide tape with 6 code holes. 6-level code provided for transmission of both upper and lower cases, as required for newspaper and book printing. Other characters were included, and the character counter mounted to the right rear allowed the typist to keep track of how many characters had been punched and what accumulated number of proportional width spaces had been utilized. The character widths varied to give the best appearing copy when typeset in the printing trades. A pin barrel selector at the left side of the unit provided special typesetting controls. The punch tape was sensed by a 6-level XD unit, and the line signals then sent were reperforated at the distant end of the telegraph circuit. The resulting tape was used to run a linotype machine within a print shop via a Teletypesetter control unit that was also made by Teletype at first and then by Teletypesetter Corporation after the latter had been spun off from Teletype. Under Morse Getz. Later, Setter was sold to Fairchild and Maury came back to run Teletype. A version of the Model 15 page printer was manufactured for use with the Teletypesetter system. This was the Model 20 using the 6th-level code. It printed both upper and lower cases at a constant 10 characters per inch, thus giving editors a printed copy of each message sent that could be used in their work. Since it did not have proportional spacing, the copy was not exactly like that of the linotype that the linotype would produce, however. Another outgrowth of the Model 15 line was the sequential selector. Switching of messages was becoming common, using sequences of characters preceded or embedded in the messages, and code detecting contacts were being added to the selector printing mechanisms. When the mechanisms became too cumbersome, a separate selector unit was designed, the sole purpose of which was to detect the sequences and cause the switching action to take place. The government's Federal Aviation Agency was the principal user on weather reporting networks. When the Model 15 turned out to be a heavy-duty machine capable of working 24 hours a day for many months between maintenance calls, the thought of producing a lower-cost light-duty machine arose. The first version was called a Model 24. It used a new variety of type wheel and stored each character after selection, the printing out not occurring until the next character was being received. This was slow and inefficient, so the design was changed to give overlap with printout occurring immediately after selection and independent of the next character's arrival. The new unit was called the Model 26. The usual Model 14 selector mechanism was used, mounted at the top front of the printer unit, while the common cam and contact sending distributor was there too. Cushion keytops were present also, seen at the lower right-hand corner. The type wheel was a rotating wheel in which the type pallets were mounted in such manner that when the selected pallet was in position between a printing lever and the ribbon paper platen area, the lever could push it back toward them with the impact printing the character. The Model 26 in one version was the first integrated ASR, automatic send-receive set, designed by Teletype. A tape punch was located at the top right-hand side of the printing unit, while a corresponding tape reader was located at the lower right side of the set. Teletype never did design both punch and reader into the Model 15 printer unit, but the Lorenz Company of Germany did, after Teletype had sold them patent and manufacturing rights in the 1930s, and the Germans then used them in their military communications during World War II. It was not until the 1960s with the Model 3233 that Teletype made a unitized ASR set. A well-preserved Model 26 KSR set was donated to the museum by Illinois Bell, complete with a small table typical of those provided for use in a customer's office. Only a few thousand were made since the manufacturing costs were found to not be much less than for the Model 15, and the services provided were limited. One serious problem was the moving carriage platen giving paper feeding difficulties. Work on an eventual replacement for the Model 15 began while the war raged overseas. Called the Model 28, it was to be made up of pre-designed building blocks that could be assembled in various configurations. Advantage was to be taken of new materials, manufacturing tools, and methods and other new technological ideas. Each version was given a code letter as it came along, with Model A being followed by Models B and C. The last one named has been preserved and has a number of interesting features. The cam and contact sending distributor was still used, but the cam was now made of molded Bakelite plastic, and the molded plastic keytops were used for the first time. We don't know the reaction of the operators who were used to the old cushion type, but the cost of the plastic style was much less and carried the day. Printing was now accomplished from a type sector, a curved arc of metal with the typefaces projecting from its outer surface. The sector was raised up to select a row of type for printing, then rotated to right or left to the chosen character. A printing bale behind the paper then moved forward, impacting the paper against the ribbon and typeface. We will see the sector again when we come to the Model 31. The Model 28 proceeded on through the D, E, and F stages. The Model D has been preserved and shows evidence of being related to the final Model 28 production design. The type box moves horizontally across the paper on the carriage riding on a rail. A single magnet selector is used, having a large coil. The rangefinder looks somewhat like the old Model 14 one. Printing carriages move back and forth across the page by being attached to spacing drums via steel cables. Above and behind the rail on which the carriage rides, flat steel belts like clock springs were used to move the type box back and forth in character selection. In later models, the belts were replaced by more steel cables. The spacing drums were much like the same elements on conventional typewriters, except that they were much larger. Here is a view of the first type box. It was fastened in place with screws, but otherwise much like the ones that went into production. The pallets were mounted between front and back plates with springs on the bodies of the pallets, providing retraction after being impacted during the print operation. The print hammer moved character space by character space across the page, while the type box moved horizontally and vertically to bring the selected character into the printing position, after which the hammer was released to impact the pallet stem and print the character. The impact power was from a stretched spring with a thumb screw at the front, giving variation in impact power when various numbers of carbon copies would need to be printed. One main feature was the use of metal drum and movable shoes type of clutch for driving rotating parts. These were miniature versions of the common automotive braking system used in reverse. Here one is seen driving the type box positioning mechanism. two serious problems were encountered in their development. Breakage of drums due to the extreme pressures involved was cured by the use of LaSalle stress-proof steel per a study made by Armor Research Institute, and gradual appearance of slippage due to the accumulation of wear products was alleviated by cutting crosswise slots into the drum working face, thereby letting the particles drop out of the way instead of getting embedded in the working surfaces. Walt Zenner got the patent on this as well as on most of the other mechanisms developed for the Model 28. This view of the back of the Model D shows the selector clutch that was tripped by the start pulse of the line signal. The selector magnet is just beyond the pointing finger. Here's a production Model 28 typing unit mounted on a base. It is a later version with a tape punch attached to the left for use in an ASR set. The production model single magnet selector had a radically different appearing mechanism, but the function was the same as in the old Model 14 and its followers. The rangefinder assembly was entirely new and was easy to use compared to the older ones. The clutch drum hung outboard of the selector itself. The print hammer and type box carriage components were mounted on a front frame assembly that could be easily detached and reattached in troubleshooting, and the steel cables were now quite visible. The print hammer had been beefed up with additional mass so as to have a greater impact during the printing operation. A U-shaped guide notch had been placed just in front of the point where the hammer will strike the ribbon against the paper at the end of the stroke, and the thumb screw for adjusting print spring tension has been replaced by notches and a cooperating lever in front of and below the hammer. The type box is easily removed from the carriage just by flipping a retaining lever which has over-centering. The pallet faces have the various characters in reverse, of course, and are also made concave from top to bottom to match the contour of the platen, thus giving even density of printing over the whole character. The back side of the type box shows the stems of the type pallets projecting out from the back plate. This is the side seen when the box is mounted in place. The round stud projecting at the right end is used as a handle when installing or removing the box from its mounted position. Within the typing unit, a function box, also called stunt box because of the many diverse functions it can supply, is mounted horizontally. It cooperates with code bars mounted parallel with it. This unit provides the line feed, carriage return, bell signal, and selective calling function operations. Electrical contacts may be mounted on its top and are operated according to received signaling characters or sequences. The keyboard has molded plastic keytops that come in various colors. The red ones at the top provide various local operations, while the green ones below are used in sending messages. And a cam-driven single contact in a metal box provides the sending distributor function. This made it easy to add filters to suppress radio interference, which had become a problem in recent years. The typing reperforator is an independent unit that is powered by a common motor in the Model 28 set. It provides punched and printed tape for the same purposes that the old Model 14 FPR unit did. The legend should be LPR, and it appears the R has dropped off the card. The Model 28 typing unit was called an LP. The newer Model 28 single magnet selector is used, of course. Behind the hand, the printer ribbon spools may be seen. The tape punches were at the lower left. Typing was by a small type wheel which was a cylinder with 4 rows of type faces on it. A single print hammer was located under the wheel and was driven upward, impacting the tape up against the ribbon and typeface selected. Early models had chadless perforations with square chads, while later ones printed the characters between the feed holes in the center of the tape. These characters were somewhat smaller than those printed on top of the chads. A complete Model 28 ASR set was on display in the museum. It contained a typing unit, a keyboard, a typing perforator, not a reperforator, a tape reader, and had room behind the latter for the mounting of an independent typing reperforator. If the typing perforator attached to the keyboard needed a printer assembly, it was just added above the punch. A 6-unit code model was developed to replace the Model 20 in Teletypesetter use. It never went into production, however. It was called the Model 29. And a Model 28 typing unit was mounted in a tight-fitting box for use in the brokerage and news bulletin business. It too did not catch on. There was always the push to develop lower-cost units for simpler systems. One such system was the Model 36 monopulse. This operated much like some early stock tickers, with the line signal being an open interval during which sending and receiving devices rotated until the proper point was reached for printing the desired character. The keyboard, at the left here, had its keys mounted in a circle, which was non-standard and took a bit of training by the operator. The sending contact was opened by depressing a key and remained open until the selecting arm reached that key after leaving its rest or stop position. Meanwhile, the selecting arm at the receiving printer was similarly seeking the printing point. When the line closed, it was there, so the printing hammer struck the rotating type wheel, printing the character. The printer type wheel was inked much as the old blue and green code printers had been. The inking roller can be seen at the top of the printer with the type wheel under it. Then comes the printing tape, the supply roll of which is at the bottom. The printing hammer is just under the tape and print wheel and moves upward to cause printing. The system was very simple and therefore low cost, but only a limited number were made. The museum contained a number of other simple, low-cost printing units that were built and studied over a 25 or 30-year interval. One of these was a so-called portable printer that could be carried around in a small case much like a portable typewriter, except that this was before the days of aluminum and magnesium castings, so it was very heavy, almost 40 pounds. It had the usual Model 14 selector mechanism and the green-colored cushion keytops. Also the conventional cam and contact sending distributor. Unique thing, though, was the daisy pedal style of type wheel, the first unit known to have this design. The wheel rotated to the desired character, after which a printing hammer impacted a pedal which had the typeface on its back side. The latter was driven against the ribbon and paper, coming to rest against the platen. The printer could carry only a small supply roll of paper which folded down to be just above the keyboard when the unit was put into its carrying case. The outgrowth of the Model 28 development work was the Model 31. This was a lightweight keyboard send-receive tape printer set that was used for sporting events where it superseded the old Morse key and operator method of giving play-by-play descriptions and sending press dispatches. It had a single magnet selector of a simplified type with a rudimentary ring spinder. The keytops were molded plastic and were actually the prototypes for the Model 28 production design when that came along a few years later. The usual cam and contact signal generator was used, and here the molded bakelite cam was proven in. The typing was from the type sector studied on the early Model 28 unit. It was turned over with a convex surface down, and its mounting was fixed, not on a moving carriage. The sector had 4 rows of typefaces, so it moved out the proper distance for a desired row, then rotated to left or right to select the desired character. The production version sector was also molded bakelite, which was found to be adequate for light duty but failed under severe service when tried in later printers. Printing was by a print hammer located under the tape, which was swung upward, pushing the tape against the ribbon and typeface. Next came the Model 32-33, the respective sets for 5 and 8 level codes. The need for upper and lower case character communications was coming to the fore, especially with computers coming into common use. The ASCII 8-level code was approved about this time, with John Arwater of Teletype being the principal proponent. The TWX network was converted to dial on the DDD, that's direct distance dialing, telephone network, and 8-level service was required. The Model 32 was the 5-level set which was used in large numbers for telex service worldwide. Most are still in service after some 20 years. It was available in the ASR set with punch and tape reader at the left side, or the tape units could be left off, giving a simple KSR set. The printer has a single magnet selector with a low impedance selector magnet that operated on 500 milliamperes of current, some 10 to 25 times more than had been used up to this time. The rangefinder for the selector was below the hand in the view shown. Since the Model 32s and 33s were to be very low cost, mechanisms were quite simple. A brush and commutator type sending distributor was used, mounted at the right side of the typing unit. Printing was by a small type cylinder, shades of the blue and green codes, which moved back and forth across the paper, which was stationary. Weaknesses in design were gradually upgraded so that the Model 32 and Model 33 were eventually known as standard duty sets and not light duty. A call control unit was mounted to the right of the typing unit and served to make connections to signal lines and to provide other necessary functions. The selector magnet was driven by a selector magnet driver which caused the magnet currents to rise and fall rapidly, giving better margins of operation than the older pulling magnet or holding magnet selectors had done. The SMD is the upright card marked 161604, and the power transistor does the actual current switching. Over 500,000 Model 32s and 33s had been made by early 1975, and the 500,000th was plated with gold and placed on special exhibit. And another 100,000 were made in the next 18 months, so that number 600,000 was painted red, white, and blue and shown around the country during the last part of and the year after the bicentennial year, 1976. Meanwhile, the Model 28 had been upgraded into 8-level service, and the new version was called the Model 35. A Model 34 5-level was also tried but did not go into production. However, the need for upper and lower case service continued, and the Models 33 and 35 were capitals only. Thus, work began on a new set designated Model 37. This was to supersede the electrical typewriters that were beginning to be used as printer terminals. It had to work at 150 words per minute compared to the 100 WPM of the Model 33 and 35. The Model 28 and 35 type box was enlarged with 2 additional rows of pallets for the lowercase alphabet, and the printing hammer mechanism was changed. This experimental model shows some new mechanisms in development. The signal magnet selector with selector magnet drive was standard, and some other mechanisms were taken over from the Model 35. The principal difference was how the type box positioning was accomplished, since this had to be 50% faster than before. New power drives were worked out. An aggregate motion mechanism was developed for the positioning and was assembled into the right side of the typing unit. This worked very successfully at 150 words a minute. Model 37 was restyled from the Model 35 and was nice appearing. However, it did not catch on in the market and soon was discontinued in manufacture. A Model 38, an 8-level Model 33, was also tried and failed. One unit was placed in a skin-tight cover and topped the pedestal. This, receive-only Model 37, apparently did not get into production. One successful derivation of the Model 37 was a stock ticker. The faster speed was very attractive to a market where no new equipment had been developed or gone into production for many years. The aggregate motion mechanism for positioning the type box during printing was laid down flat with a box coming above the wide tape used in the stock market quotation business. A standard ribbon was used. The typing unit was housed in an attractive cover marked with the name of the service provider, in this case, the New York Stock Exchange. Where a table was not available to put the unit on, a companion pedestal could be supplied. Since we're talking about stock tickers, perhaps we should get into some of their history. 2 very old versions had been donated to the Teletype Museum. The first is one invented by Thomas Alva Edison. It was covered by a glass bowl, a common use where instant visibility of copy was essential. With the cover removed, the type wheel is visible. It was inked by a felt roller that was carried on a box above the type wheel. From the back, the mechanism can be seen. Operation was from an escapement mechanism that was related to a clockworks. Local power was from a hand-wound clock spring or possibly a depending weight. The other ticker is a New York Stock Quotation Company variety, also with a glass bowl overhead. Its mechanism was different. The principle is similar to the monopulse, with the line being opened at the beginning of a character transmission and closing at the proper instant for printing the selected character. The power for printing came from the line current pulse that then appeared. Teletype developed stock tickers well after the others had appeared. 2 models are on display. One is the Markham high-speed ticker, which appeared in the 1920s. It was the one in service during the prosperous times following World War I and continued in use until superseded by the Model 37. It used a pin barrel type of selector mechanism to which the type wheel directly attached. Again, the type wheel was inked by a felt roller contained in a box above the wheel. A faster design than the Markham ticker was developed to be a replacement. It was called the Model 16 and was a sensation in its day, but only in the laboratory. It occupied a minimal floor space and used standard typewriter ribbons. Looking down from the top, the principle is clearly evident. 2 banks of type bars were used, located on both sides of the wide tape, which would run from bottom to top in the picture. This allowed very fast printing, much faster than the rather sluggish Markham ticker printer. But one problem remained, the economic factor. It was brought out at the beginning of the Great Depression and there was no market for it. Thus, the old Markham continued to be used, and a few more units were even produced during the next 30 years or so until the Model 37 unit came along. We now enter the modern era of teletype developments, but not all of them are represented in the museum. One model happens to be the first Model 40 typing unit. This had a moving horizontally mounted belt to which printing bars were attached. These were also the armatures of a row of print solenoids that were mounted onto the platen at the rear. A close-up shows more details. The typefaces are at the top of the printing bars, and when a print magnet for a particular column was energized at the right time, the printing bar's armature would be attracted to the rear. Since the bar was pivoted at its bottom, the typeface at the top would impact the ribbon and paper against the platen, printing the character. The next model turned the type belt up on edge and placed standard Model 28, 35, 37 pallets in it in a horizontal position as in typebox printers. Now a row of print hammers at the rear of the unit fired at the proper instance to get character selection and printing in the desired column location. The print hammers were found easiest to make with flat faces, so the type pallets were made that way also. Printing was on a print-through basis, and copy could not be read until the paper had fed upward a short distance. The first complete unit had a large platen above the printing point for paper feeding purposes only. In other respects, the experimental unit was much like the production design. That looked like this. The final unit was quite compact and was easy to service, change the pallets to another arrangements, and so on. Looking up close, we now see a smaller platen for paper feeding and a simpler, though still circuitous, ribbon feeding route. Instructions for the latter task were given on a label pasted on the top frame. This unit is still in production and selling well. A narrow paper version of the Model 40 printer unit was made for portable and mobile use. It was field tested in one of the new radio telephone networks and for police use, but did not catch on and was abandoned. Since the Model 40 was rather overpowering in its complexity, simpler designs were sought for mobile and portable service. One of these was very compact, mounting easily on the hump in the front floor area of police cars. Inside, it had a motor-driven type belt on which the typefaces were directly molded. The left-hand pulley, around which the type belt passed, was mounted on an arm that was pivoted at its other end. Printing was accomplished by swinging the arm until the selected typeface on the belt impacted the ribbon against the paper, which was wrapped around the platen. The printing mechanism was mounted on a horizontally oscillating carriage for column selection. This set also did not go into production. In the 1960s and 1970s, Teletype designed and produced a number of high-speed tape units. One of these was the DRPE, a punch that worked at up to 2,400 words per minute. This was included in a line of equipment titled Data Speed or Telespeed. In the laboratory, one DRPE was equipped with an overhead triple bank of magnets attached to printing wires which dropped down so their ends could impact a ribbon against the punch tape. This caused the printing of dot matrix characters on the tape, simulating the output of the old typing reperforators. Again, no market. And now for a couple of originally classified items that came out of the old 50 lab. The first is a tape printer that used the type wheel for the printing function. And the second is the keyboard send-receive unit in which the printer was used. There was a 5-unit set with code scrambling facilities at the top. The keyboard seems to come from the Model 28. The set is long since obsolete in these days of electronic chips and computer developments. Another set developed in the intervening years was the 4210 magnetic tape send-receive terminal. It was used with the Model 37, for which it was mounted in this special cabinet. The magnetic tape was housed in a cartridge with a leader extending from it. The cartridge was mounted at the rear, the leader was pulled forward through a slot alongside the recording reading head, and then was wrapped around a capstan on which the spent tape collected as the tape was read or recorded. At the end of the operation, the tape was rewound back into the cartridge. This set was produced for several years. Another development that was ahead of its time was the Inktronic. The principle was discovered by Charles Winston in the late 1950s and took several years to get developed. This receiving-only printer operated at 1,200 words per minute and cooperated with data speed devices. Only a couple thousand were made before it was manufactured discontinued. Since then, other manufacturers are turning out similar devices with some commercial success. A send-receive Inktronic set was developed but never put into manufacture. It used the console from the CDT, Communications Display Terminal, which was the predecessor to the Model 40 keyboard display unit. The keyboard came from the Model 37. And now our last set of equipment. a combination CDT and Inktronic that was assembled for market testing purposes. The CDT tube, keyboard, and controls are at the left, while the Inktronic printer unit occupies the right half of the cabinet. The dial and phone tell us that this set was intended for data phone service by the Bell system. In spite of being the first hard copy, soft copy set made, it never got beyond this point in the marketplace. Our tour of the old museum is now complete. We have not covered all the equipment that is in museum storage, and the storage does not contain samples of all the various types of equipment that were developed down through the years. For example, large sets, such as the vacuum tube electronic multiplex developed in the late 1940s, were too big to be in either the museum area or in storage. Many cabinets, such as those that house multiple sets of printers, tape punches, and readers, and so on, just could not be accommodated. But we hope that you have had a good pictorial tour and have developed an appreciation of the hard work that was done by many engineers and their associates in keeping teletype at the forefront of progress down through the years. This is Ransom Slayton, your verbal escort for your Teletype Museum Tour.